Okay, so on this video, we're going to just cover the acceleration transformations. These are the Lorentz acceleration transformations. So just to remind you, here was our Lorentz transformations. Again, this is from Mary to Frank, Frank to Mary. For the position in time, these were the transformations for the velocities that we just recently did. Now, if you look at your second homework assignment, the very last problem, I asked you to derive the acceleration transformation from Frank to Mary in the y direction. Now, I'm not going to do it this one right here, but I'm going to do the one for the x direction right here, which namely would be, what is ax prime? That way in the homework, kind of follow what I did for the x, but do it for the y. Okay, so what is the definition of acceleration? It's du x prime dt prime. Okay, that's the definition. Now I can't just come over here and take the derivative of this because it's with respect to this one, because it's with respect to t prime, and these are unprimed. So I'm going to just apply the chain rule to this, which means we'll just write this as du x prime dt prime. Okay, so you can see these two cancel out and you get exactly what you had before. So I just have to solve and plug in du x prime dt and plug in dt prime and multiply them together. So let's do this. So first of all, let's get this right here. So what we have to do is we have to go back to ux prime, which is right here, and we have to take the derivative of that with respect to time. Well, I got ux's in the top and in the bottom right here of the fraction, so I have to use the quotient rule. So what do we have? We have the bottom, which is 1 minus uxv all over c squared times the derivative of the top. That's a constant, so that's 0. The derivative of that with respect to time is ax. So that's ax minus the top, which is ux minus v, times the derivative of the bottom, which is, the derivative of that is 0. So and that's a constant, so it's just minus ax v over c squared. So this is minus times the derivative of the bottom, minus ax v all over c squared. Okay, all divided by the bottom squared, which is 1 minus ux v all over c squared squared. Okay, so that is this term right there. Now we just have to multiply it by that term, dt prime. So where's t? T is right there. We want to take the derivative of that with respect to t prime. Well, this is all a constant, so the constant's still there, but the derivative of the numerator right here, derivative of that with respect to t prime is 1, so that's 1 plus, taking the derivative, that's constant, v over c squared, and the derivative of that with respect to t prime is ux prime. So it's plus ux prime v over c squared divided by the square root of 1 minus v squared over c squared. Okay, so there is those two terms, this term and that term. Now, the only thing is, I don't want any primes on this side, and I can see a prime right there. So I need to plug in my ux prime into that spot, which is this. I need to plug that right in for my ux prime. So what I'm going to plug right into here is ux minus v all over 1 minus ux v over c squared. So I'm just going to plug that in. Now hopefully I can simplify this while I plug it in. Okay, so we've got ax prime equals, well, let me pull out whatever I can here. I can pull out an ax out of these two terms, so I'm going to pull that out, ax. Okay, and then I can pull this out and that out. I can pull all that out. So we got 1 minus uxv over c squared and a square root of 1 minus v squared over c squared. Okay, and then I've got this numerator here with the a gone. Now, I noticed here I can get rid of the two minuses here, make that a plus. So what I'm left here is 1 minus uxv over c squared. So I'll just put it right here. 1 minus uxv over c squared takes care of this. We pulled out the ax, so then we got plus uxv over c squared plus uxv over c squared. And then the last term is this times this. We already pulled out the ax, so it's minus v squared over c squared. Minus v squared over c squared. And then we still have this term. We pulled that out. So we still have this term with that plugged in. So we have 1 plus we've got all of this, ux minus v, all over 1 minus uxv over c squared, minus uxv over c squared. And then we still have this v over c squared times v over c squared. V all over c squared. Okay. Okay, now what I think I'll do is I think I'll get a common denominator between these two right here. So if I put a 1 minus uxv all over c squared and do the same thing down below, 1 minus uxv over c squared, 1 minus uxv over c squared. I'm just going to make that, so that way I can, oh, also right here, this was squared, that was squared, so this is still squared. I have to make sure don't lose that square. But now I have another one over here. I'll pull that out, and so this is now going to be cubed. So we got ax prime is equal to, so on the bottom, I'm going to have a 1 minus uxv all over c squared cubed, 2 from here and 1 from over there. We have the square root of 1 minus v squared over c squared, so there's the entire denominator. I noticed that these two terms canceled. So this cancels with that. So we still have the ax here. And then we have a 1 minus v squared over c squared. 1 minus v squared over c squared. And then over here, we have 1 minus uxv all over c squared. It's this term. And then we have this multiplied plus uxv over c squared minus v squared over c squared. Okay, and then this term will cancel with that term. And now we just have a 1 minus v squared over c squared. I can put that with this one, so that's squared. And so we're left with ax prime is equal to ax. Well, since this and this gives me that term squared, and then I have a square root on the bottom, so that's to the 2 minus a half power, which is 3 halves power. So this is 1 minus v squared over c squared to the 3 halves all over this term, because that term canceled right there, 1 minus ux v all over c squared cubed. So there is the transformation for the x component of the velocity right here. It's getting a little bit more complicated as we keep taking more and more derivatives here. Now the one you had to do was this one. Follow the same kind of procedure. One thing you'll notice here is that the y component of momentum in Mary's frame depends on the y and the x component in Frank's frame. But you're going to follow the same sort of procedure right here. Do this, but with the y. Okay, and hopefully this is the last problem on chapter homework assignment 2. So go ahead, now you can work it out.